the Brooklyn Bridge in New York City and the Golden Gate Bridge in San Francisco are two of the most iconic bridges in the world. Each was a record breaker in its day, capturing the public's imagination and redefining what a bridge should be. But that, as they say, was then. This is now. What can these legendary works of engineering teach us about bridge building today? And if designers had to start all over, what would they do differently? Let's find out. First, let's take a quick look at how each bridge came to be. The Brooklyn Bridge opened on May 24, 1883. It was the first man-made crossing over the East River, connecting the boroughs of Manhattan and Brooklyn. At the time, it was the longest suspension bridge in the world, spanning nearly 1.1 miles at a height of about 127 feet above the East River. It was also the first to feature steel wire cables in its construction. In terms of design, the Brooklyn Bridge is actually two types of bridges in one. A suspension bridge, with the cables supporting the road deck attached to two main cables draped over two towers, and a cable-stayed bridge, with some cables attached directly to the towers. To prove that translated into one sturdy design, circus mogul P.T. Barnum famously led 21 elephants over the Brooklyn Bridge on the eve of its one-year anniversary. Unlike the Brooklyn Bridge, the Golden Gate Bridge is all suspension and longer. At about 1.7 miles long and 746 feet tall, the Golden Gate Bridge was both the world's longest and tallest suspension bridge when it was built in 1937. Today, it's best known for its iconic international orange color and has been declared one of the wonders of the modern world by the American Society of Civil Engineers. Two things that unite these famous bridges are their unmatched grace and their rich history, which could never be recreated, of course. But if designers back then had access to the modeling tools, materials, and methods of construction we enjoy today, what would they have done differently? One obvious choice would be to use a computer to draft the design rather than pencil and paper. Up until very recently, when bridge builders said they had to go back to the drawing board, there was literally a drawing board for them to return to. The only figurative part of that phrase was that it was just a single person who was doing the drawing. Back when the Brooklyn and Golden Gate bridges were constructed, architects worked with teams of drafters who would translate their sometimes nebulous ideas into highly detailed, realistic plans. The tools of the trade were the T-square, compass, pencil and pen, and reams of tracing paper. Today, those tools have been digitized to forms fit for CAD, short for computer-aided design. CAD software has vastly reduced the amount of time that goes into producing architectural drawings. A series of points and clicks can take designers from simple wire sketches to hyper-realistic models in a matter of hours. But it's safe to assume that with access to high-tech drawing software, the planning teams behind the Brooklyn and Golden Gate bridges would have been considerably smaller. Another point of departure would be the materials used for construction. When they were built, the Brooklyn and Golden Gate bridges represented a new class of bridge. Some of the building materials were familiar: concrete for the road deck, and in the case of the Brooklyn Bridge, limestone and granite in the towers. But their steel wire construction marked a shift away from iron, which had long been the bridge building material of choice. If designers had to do it all over, however, they might reconsider using steel. Despite its strength and visual appeal, steel has translated to some hefty maintenance costs for both bridges, especially the Golden Gate. Road contamination, UV rays, and the salty air of the San Francisco Bay would wreak havoc on the bridge's steel if it weren't for its distinctive and protective coat of orange paint. To save on those costs, builders today would likely incorporate lighter and more sustainable materials, such as fiber-reinforced polymers. These composite materials require virtually no maintenance, can be produced much faster than all concrete or all metal parts, and because they put less stress on the overall structure, they could allow for longer-lasting bridges. Then, of course, there's the matter of putting the bridges together. It took 14 years, 600 workers, and $15 million to build the Brooklyn Bridge. The Golden Gate was a much speedier project, completed within 4 years, but it was also more expensive, costing approximately $35 million to build. Labor is undoubtedly the largest bottleneck of any construction process, but while human power has remained largely the same since the Brooklyn and Golden Gate bridges were constructed, machine power has exploded. Today's construction sites feature an all-star cast of machines designed to make bridge work much easier. Some of the largest and most complex of these machines can install entire concrete beams between supports, vastly reducing construction time. And who's to say designers wouldn't use even newer technologies like 3D printing? Printing an entire bridge would be an extraordinarily tall order, even today, even though in principle it is possible. But 3D printing individual parts could be one way to cut time and cost. Perhaps the biggest savings made with modern construction techniques is in the loss of human life. 20 people died during the construction of the Brooklyn Bridge, including its designer, John A. Roebling, who succumbed to tetanus from a nasty foot injury sustained on site. The Golden Gate Bridge claimed 11 souls. While safety isn't guaranteed on any construction site, it's not hard to imagine that workers on a new Brooklyn or Golden Gate Bridge would be placed in greater peril today. Despite their age, the Brooklyn Bridge and Golden Gate Bridge won't be replaced anytime soon. Continued maintenance and a watchful eye should extend the long life the two bridges have already enjoyed. We can marvel at how modern materials and technology might have improved the two colossal structures had they been accessible during their construction. But there's one thing that simply can't be altered or bested: the special significance the bridges hold for tens of thousands of motorists, cyclists, and pedestrians who traverse them each day.